Hey guys, good morning, happy Thursday. Just wanted to talk to you guys about some weighted average problems. I'm really hoping that going through those equations again yesterday was helpful, seeing them solved, and hopefully you did a little bit better on your homework this time, fix some of those mistakes. A lot of you make sure that, I know I commented to you online, make sure that you're showing all of those steps the same way that I did. All right, show each step and how it worked and how you got to the answer that you got to. That's really, really important. As we continue, we're going to talk a little bit about these weighted average equations, which are a little bit tougher. I'm not even sure if you guys can read that. This is literally just example 3 under section 1-2 from your book. So if it helps, you can pause this and pull it up and you can read it. But basically it says a lab tech needs 25 liters of a solution that's 15% acid for a certain experiment, but she only has a solution that's 10% acid and a solution that's 30% acid. So she needs 15%, she's got 10% and 30. How many liters of 10% and 30% solution should she mix to get what she needs? So what she's looking to get is 25 liters of this 15% solution. So the first thing we know, when we're talking about weighted average problems, anything with percentages, we always change a percent to a decimal when we go to solve that problem, okay? So in this case, when we're changing here, we want to change 15%, 10%, and 30% all into decimals when we go to use them. So, first thing we're going to do, let's start with this side here. So we have 25 liters of a 15% solution. And we want that to equal these other two combined. So we don't know how much of each one we need, but that's what we want to kind of solve for, right? So we know that of the 10%, we want X amount. We don't know how much that is. And of the 30%, this is where it gets kind of tricky, I would say. We don't know how much we want either, but we know that we want a total of 25 liters. So if we want X of the 10% solution, how do I make this variable so that I know that they add up to 25? What we're going to do is we're going to say that I want 25 minus X of the 30% solution. Take that in for a second. X amount of the 10%. So let's say this was 2 liters. 25 minus 2 would be 23 liters because we know we have to add up, at the end we want to have 25 liters. So that's how we're going to do that. We're going to do X for one of them, and then we're going to do the amount, 25 in this case, minus X for the other one. Okay? That I know is probably kind of confusing. That's okay. I'm going to grab a calculator while you're still there. My calculator ran out of batteries, so I had to grab this other one, okay? So we're just going to do a little bit of math, right? So this 25, 15% of 25 is 3.75 over here. And then we don't do anything with 0.10x, but this looks like distributive property on this side. So we're going to do 0.30 times 25, and that's going to give us 7.5. And 0.30 times x is going to be negative 0.30x. So far all we did was we distributed on the right side and we multiplied over here. Okay? From there, kind of like what we did, here's some like terms. Negative 0.30x plus 0.10x is going to be negative 0.20x plus 7.5 equals 3.75. Now it's just a two-step equation from there. So we're going to subtract 7.5, subtract 7.5, and that's going to give you negative 0.20x equals, what's that, negative 4? Nope. Negative 3.75? Oh, right in the middle. All right. And then we have one more step, which is going to be divide by negative 0.20, divide by negative 0.20, and x is 18.75 liters. So we need 18.75 liters of the 10% solution. And then if we do 25 minus that number, we need 6.25 of the 30% solution. And that's kind of crazy, but it's very real world, because if we're really trying to get to this 15% solution, we got to figure out how much I have to add of each of these things. So yeah, making sure that it focuses on the math there. That's what you get. Now, what's really cool in your interactive book, if you did click on this problem and you click solution, I have a marker in my hand. There we go. It kind of works you through, step by step. This is what we did, and it will keep going to get you where x is, and then you can interpret, and it does exactly what we said and shows you how much of each one. So that's what's really nice about these examples, is that you can just see step by step kind of what they're doing. Now it's a little bit more confusing. I feel like hopefully it helps when I'm talking about them to you guys, and it doesn't get as confusing. All right, I'm gonna do one more with you, and then I'll give you a couple, well, you see the couple that you have to work on. Let's do example, Example 5. I'll pull it up here. And again, if you want to look on yours, if that helped you, do we not have example 5? Oh, I can scroll. There we go. Let's try this one. Yeah, okay, cool. So let's see, Latanya will walk her bike from her house to the bike shop. We have a little map here. It's 1.5 miles from her house to get the bike fixed. She expects to wait 30 minutes for the repair. Then she will ride her bike home. Can she be home in 1 hour? Well, that's an excellent question. So she's gonna, it says over here, this is important if you can't see it. I don't think you can actually. I'm looking at the map and it's pretty fuzzy. I'm not sure. Maybe I can get ask if I can get a better smart board bulb. But I feel like it's not looking very good. Anyway, right here it says that bikes go 10 miles an hour. So the bike travels at 10 mph. And walking is 3 miles per hour. We're going to need that. Because what we're going to have to do here is break this one down into what's happening per hour the whole time. So it's kind of like that weighted average we just did, only this time we're talking about different speeds. So we know we want to add the total time and see if it's 1. That's kind of our goal. So let's talk about these walking times. So we have 1.5 miles that she's going to walk. So how do we figure out how much time that is, right? So if you think about this, 3 miles per hour is miles over hour equals, however we got that, is 1.5 miles over blank hours. So let me do a little sidebar here. When we're talking about miles per hour, anytime you hear per, is going to be division, right? So if we're saying it's 1.5 miles, we don't know how many hours, but that is going to be her speed of 3 miles per hour, right? To get there. So, if you, I'll show you this the first time and then it will hopefully make sense, but if I wanted to solve this for x, I can't solve it if it's in the bottom. So I'd have to multiply by x on both sides to cancel that out, and that would give me 1.5 equals 3x. And then I would have to divide by 3 to get x by itself. And so x would be 1.5 divided by 3, whatever that turns out to be, which I think is a half, right? So basically what you're going to do, if you want to find out that time is going to be distance divided by rate is going to equal time, okay? So I'm going to come back over here and we'll jump right into that, okay? So I know that for walking, because here's what we got. We got walk plus fix plus bike, and we need that to equal 1 hour, hopefully. So the walking part is going to be 1.5 divided by 3. The distance divided by the rate. How long is the fix? Well, in here it said 30 minutes, but you got to be careful because when we're talking about minutes, everything else is in terms of hours, miles per hour, right? So what would 30 minutes be as an hour? That would be 1/2. So let's just use 1/2 for the fix. And then for the bike, we're going to do the same thing we did for walking. The bike moves at 10 miles per hour. So that would be the distance, 1.5, divided by the speed, which is 10. And we want that to equal 1, hopefully, right? So let's do a little bit of math. 1.5 divided by 3 is, like I said, let's just do decimals. That'll be easier, hopefully. I think I'm going to cut off the bottom of this, aren't I? Let's do it over here. So that's going to be 0.5. 1/2 is 0.5. And 1.5 divided by 10 is going to give me 0.15. So if I add those up, you probably already see the problem. That's going to be 1.15. So can she be home in an hour? No, she cannot. Because it's going to take her 1.15 hours to get home. So she was close, but didn't quite make it there. All right, so those are some trickier ones where we had some rates, we had some percentages that we added in. So I'm hoping that your example, I'm right here. I'm hoping your examples for homework I'm only going to give you a couple of these. Again, don't stress. If you have a question, send a remind. I know these are kind of tricky too. But hopefully you can model them after these two examples that we got to do together. All right, That's it for me. Good luck on your work. All right, I'll see you tomorrow for Friday. Woohoo!